It's the first Monday in September.
I'm working next to you on the weekend. Hey, girl, what are you doing?
Miss Jones.
All right, I'm recording just to let y'all know. Yeah. Yeah, and I don't have my filled in copies. I don't know what I did with them. All right. It's a good day when you lose stuff in 2 seconds. Maybe I would.
Miss Jones.
So by the end of this section, you should be able to estimate the relative locations of median and mean on a density curve. Use the 68, 95, 99.7 rule to estimate areas, proportions of values in a normal distribution, and use table A or technology to find the proportion of z values in a specified interval, blah, 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 blah. Everybody good with that? Okay. Next. In Unit 1, we developed a, people, be on time. Troublemakers, I'm telling you. All right. We developed a kit of graphical and numerical tools for describing distribution. So the first thing you're going to do is always plot your data. You're going to look for overall patterns. And outliers. Just FYI, anytime it tells you to describe anything, graph, data, shape, center, spread, outliers. You guys missed that on your test. Remember, I told you multiple times, shape, center, spread, outliers, and you have to describe all of them. Some of you did female, male mean, or whatever. I think that's what it was. Female mean was a little higher than the male mean. I don't know if that's the right answer, but I'm just giving you an example. And then you moved down. Well, that only did center. You didn't tell me a shape. You didn't tell me a spread. You didn't tell me anything about outliers. Okay, so you got less credit for that. Okay. 3 is calculate numerical summaries. To briefly describe center and spread. What can we calculate to describe center and spread? I'm not asking for a formula. I'm saying, what are we going to calculate for center and spread? Mean and median for center. Spread is range, IQR, or standard deviation. You got it?
What did you say for summer?
Center is mean or median.
That's to do what?
That's what you're.
Jones, I have a question.
Hold on just a second. And spread is IQR, range, or standard deviation. Yes, ma'am.
Okay, so I tried to ask you before we started the Zoom, but my mic wasn't working. But I was just wondering if you got my message on Canvas.
I did, but I haven't looked at it because I was teaching.
Okay.
All right. In this section, we're going to add one more step to this strategy. And that is sometimes the overall pattern of a large number of data is so regular that we describe it by a smooth curve. So that's what we're going to talk about. So sometimes
Ms. Jones, I could breathe at least as squeaks.
I said you could pick your seat and you chose that one.
I always
So
get the squeaky chair. I pick up my pencil, go to the next word.
sorry, this is of a large number of data is so regular that we describe it by a smooth curve. So what we're going to start talking about is that normal or that symmetric, roughly symmetric curve. All right, when you're done, flip it over. All right, so for density curves, you guys see the histogram underneath, and you see that there is a smooth curve that identifies that histogram. Okay, so that smooth curve is what we're going to start talking about. This histogram shows the scores of all 947 seventh graders in Gary, Indiana on the vocab part of the Iowa Test of Basic Skills. Scores on this national test have been very regular distributions. This histogram is symmetric with both tails.
Can you move your paper up a little bit?
That fall off smoothly from a single center peak. So this one is unimodal. There are no large gaps or obvious outliers. The smooth curve drawn through the tops of the histogram bars.
Please pardon this interruption. If you are on Zoom with everyone, if you could just hold tight for a second. I forgot to make the announcement about our meal ordering. Students, the state of North Carolina is providing free breakfast and free lunch to every student in the state. If you are on campus, you can get free breakfast and free lunch. And they are also providing free breakfast and lunch on your remote days. So you will be ordering, you will let your fourth period teacher know, and y'all, fourth periods can decide how they want to do this, but you can let your fourth period teacher know if you would like to take meals home tomorrow afternoon. Every student here will get 3 breakfast meals and 3 lunch meals for next Monday, Tuesday, and Wednesday while you are working your notes. So at this time, or in the next couple minutes, teachers, you all have those pink slips. I need one filled out from every teacher, even if you have 0 kids, write 0. I know that the slip says number of meals, but all the cafeteria needs is the number of students who need the meals, because every student gets the same thing. So if you have 3 kids who need to take meals home, 3 is what you're going to put. If you have none, put 0. We just need to document and keep up that we've collected them from everyone. Also, if you're a bus driver this afternoon, those bus numbers may change from what you wrote this morning. So there are lists going out to the bus lot. Please check those. Buses will leave immediately. So as soon as the bell rings, please go straight to the bus that you need to be on. Thank you.
Anybody want meals? Nobody? Okay, that's how it was last. Yeah, I did. Okay. So the first figure shows the leftmost bar shaded. The shaded area represents the proportion of students with vocabulary scores less than a 6. There are 287 such students who make up their proportion, 287 out of 947. So it's just describing this bar up here. In other words, a score of 6 corresponds to about the 30th percentile. The total area of the bars in the histogram is 100%, which is a proportion of 1. So we always want 100% or a proportion of 1, because all the observations are represented. Now, look at the curve drawn through the tops of the bars. If you look at the second histogram, the shading to the left of 6.0 is under the curve. So again, if you see it, the shading is under the curve instead of in the bars. So what happens is that all of this little outside bar shade actually fits under the curve. So it'll fill in those gaps. So that's what it's showing you. So it's very close to that. That's why we can identify it with that curve instead of just the histogram. Okay. And moving from histogram bars to a smooth curve, we make a specific choice. We adjust the scale of the graph so that the total area under the curve is exactly 1. The number 1 is exactly 1. Now the total area represents all of the observations, just like with the histogram. So again, what I said was they took the stuff that was over the curve in part A and they slid it underneath the curve in part B. The shaded area under the curve represents the proportion of students with scores lower than 6.0. So they are 6.0 or lower. This area is 0.293, which is only 0.01 away from the actual proportion of 0.303. So what it's saying is once I put it underneath there, it's not going to get it accurate exactly right, but it's going to get it super, super close. Okay. So our estimate, so our estimate based on the curve, that is a score of 6.0, falls at about the 29th percentile. So before it was the 30th. With the histogram, it was the 30th. With this one, it's in the 29th. You can see the areas under the curve give good approximations. Sorry, that line was not long enough. Of the actual distribution of the 947 test scores. In practice, it might be easier to use this curve to estimate relative frequencies than to determine the actual proportion of students by counting data values. All right. So one thing that my students typically have trouble with are density curves, and they're really, really easy. Okay, they're not hard, but you make them more complicated than what they are. So a density curve is a curve that is always on or above the horizontal axis and has an area of exactly 1 underneath it, which means that is 100% of the data. A density curve describes the overall pattern of a distribution. I'm trying. Get me out of the way. That's not, it should say the area, sorry. Sorry, y'all. The area under the curve and above any interval of values on the horizontal axis is the proportion of all observations that fall in that interval. And again, that might not make any sense in a minute. We'll talk about density curves and I'll help you out with that. All right. No set of real data is exactly described by a density curve. The curve is an approximation. That is easy to use and accurate enough for practical use. And then when you're done, flip it. I don't have that pink slip. I didn't have that the other day. Please, thank you. Nobody, no, no. It's bowl free. Take the chocolate milk to your family. What? Yeah, you know, I got it this summer, and like Sadie will drink the chocolate milk and the apple juice and stuff like that. Or like the cereal comes in like the package container. We can throw it in the car when she's, you know, so it's good for us. But yeah, but like some of the stuff my kids wouldn't eat either. So, I mean, push it on. But the stuff that they do, like last week's stuff came with, I mean, Monday and Tuesdays. When they got it on Tuesday, it had like the white powder donuts. Everybody eats those things. I mean, you know, you can get a few things. That's cool. Y'all don't eat those? Who don't eat them? Really? White powder, I like those. They're the only like cake donuts I really like. All right. Sorry, y'all, we got interrupted. I apologize. All right, density curves. The median of a density curve are equal area points. It is the point where half of the area is to the right and half to the left. So they kind of give you these pictures to understand if it's perfect, if it's a perfect normal curve or symmetric curve, it's obviously going to be right in the middle because it's going to be balanced. That's why it's called symmetric. It's balanced on either side. But if we have skew, then the median is going to move towards that higher end to help balance out that low end. Does that make sense? Does everybody see that? So that's what it's talking about, the balance points. All right. That's pretty, that's pretty much all on that part. Mean of a density curve is the point at which the curve would balance if made of solid material. So again, it just shows you some figures where the mean would be if it needed to balance it out. Okay. And what you can barely see is they have these little triangles where it shows that balance point underneath those lines. So what this is saying is if we tried to put it in the middle, this end would be too heavy. If we put it too far over, this end would be too heavy. So you need to find where it actually balances out. That's all those pictures are showing you, okay? Distinguishing the median and the mean of a density curve. The median, again, just to remind you, has equal areas. The mean is the balance point. Okay. All right, check your understanding. Explain why this is a legitimate density curve. Why is it legitimate? Perfect. Area under curve, or the total area equals 1. About what proportion of observations are between 7 and 8? 12. So that 0.12 means that 12% are underneath there. Okay, and again, this is just from your figures. You're going to see figures like this later on. Mark the approximate location of the median. What's the median got to be? It's going to be in the middle or equal area. So your median is actually going to be more towards the top of that, like the actual peak of the curve, because it's a little bit skewed, right? Everybody see that? It's a little bit skewed. So your median is going to be more over here. And this is an approximation. Guys, this is showing your work. And what skew is this one? It's left skewed because the tail is on the left, correct? All right, so whatever skew it is, your mean should be pulled towards that skew, okay? So if we're trying to balance it, it should be pulled that way. So your mean is actually going to be somewhere over here. Okay, your median is going to be the halfway, make it perfect areas.
How is the area under 1 of 42?
The total area under this curve is always 1, no matter what. That's what makes it a density curve.
1 what?
1 whole unit. Doesn't matter what units we're talking about.
In all of, or maybe.
This is 100% of the data.
Yeah, okay.
Yeah. Okay.
What do you say that? Where's the?
What are you confused about? See what?
The one.
Right here. Total area under curve equals 1. You just can't see it because it's blurry and little.
It's like one.
Are you talking about you can't see that this equals 1?
Yeah.
It's just 100% of the data is contained under that
So
curve.
what does it mean when it says below?
What part said below 1?
I guess what it is.
Okay. We might talk about it during advisory. Just
I think I know what I'm talking about. I just can't, I don't know how to describe it.
That's kind of the same question I had. I was confused why it was a 1,
Yeah.
but that's like 1.0.
yeah, 1.0. A percentage, 100%. All right. Normal distribution. Normal curves are curves that are symmetric. And normal distributions are distributions described by normal curves. All right. So look at the 2 normal curves that illustrate several important facts. These are both normal. One is just a little bit taller than the other. That's not a big deal. The first one is that all normal curves are symmetric. Unimodal and bell-shaped. Okay, all normal curves are symmetric, unimodal, and bell-shaped. What did I tell you we're going to use for center and spread of normal or symmetric curves?
Median?
Not median, mean and standard deviation. Good. So they are described by mean. And what represents mean? What symbol? X bar.
X bar.
Perfect. And standard deviation? Which is S sub X. Or it could be this if it's population, but we don't, most of ours are going to be sample until we get later further in. The mean is located at the center changing the mean without changing the standard deviation moves the whole curve left or right. If you change the mean, remember if we make the mean +4 or +5, it's going to move to the right. If you make it minus, it's going to move to the left. That's it. And then your standard deviation controls your spread. All right. A normal distribution, we're gonna have to go out and come back in because we got interrupted a million times, but we'll get there. It's described by a normal density curve. Any particular normal distribution is completely specified by two numbers. Should say numbers, sorry. And that would be the mean and the standard deviation. The mean of a normal distribution is the center of the standard normal curve. The standard deviation is the distance from the center to the change of curvature points on either side. All right, so that little part, just to help describe it, if you're talking about the normal, the center is going to be the mean, and then the standard deviation is going to be on either side the same distance from the mean. That's all that little paragraph's saying. Okay. Everybody good? Good now? Everybody else okay? All right. All right. We abbreviate the normal distribution with mean. Remember, mean can also be mu, and standard deviation as n, which stands for normal, and it is a capital N, and like a coordinate, mean, comma, standard deviation. Normal distributions are good descriptions for some distributions of real data. Distributions that are often close to normal include test scores. You guys ever heard of a bell curve? Teachers grading on the curve. That's what they're talking about, the bell curve. It's exactly what they're talking about. So the mean average would be a C. And then they would give you your extra points or not points based on where you fall on that curve, if that makes sense, okay? Repeated careful measurements of the same quantity. Repeated careful measurements. I can't spell. So the diameter of a ball.
Like the diameter of the same ball.
Same type of ball, yeah. And the third one are characteristics. Of biological populations. That's just in general. Test scores are the ones that you're going to remember the most because that's the one grading on the curve and stuff like that you've heard of the most. Normal distributions are good approximations. To the results of many kinds of chance outcomes. Chance outcomes are like rolling dice. And third, and most important, we will see that many statistical inference procedures are based on normal distributions, which is what we'll do. Even though many sets of data follow a normal distribution, but many do not. If they don't, we figure out how to fix it, okay? All right, we good? All right, so if you're on Zoom, we're gonna go out and come back in right now, so that way we're at a good break point. So I'm gonna stop sharing, stop recording.